Physical science, it's week 3. I'm going to go through a little tutorial on how to calculate gravity based on an object's height and the time that it free falls. And this will relate to the lab that we're going to have you guys analyze. Mr. England and I collected some data last week. You guys will see videos of it. And you're going to use that data to analyze and calculate how strong and how quickly Earth is accelerating objects towards itself when they fall. So let's get into it. So here is a formula. Now this formula relates the height of an object to the time that it's going to take to fall from that height and gravity. So it says the height is equal to 1/2 times gravity's acceleration, and I have g put in there. G on Earth is 9.8 meters per second squared. We're going to do another little example here in a second where maybe you're on Mars and the acceleration is going to be a little different than that. But for now, we know gravity due to Earth's mass is 9.8 meters per second squared. And an object takes 3 seconds to hit the ground. So we drop that blue ball from some height, we time it, and it takes 3 seconds. Now 3 seconds is a pretty long free fall, so this is going to be a pretty high ledge that this person's throwing the ball from. So to calculate it, we're just going to plug in what we know. So we know time is 3 seconds. We know gravity. So if I say h equals 1/2 times 9.8 meters per second squared times 3.0 squared, 3.0 seconds squared. Order of operations, I know you guys probably are talking about this in math. You do your exponents before your multiplication. So I'm going to do 3 times 3, right, to square it. So that's equal to 9. So that's 9 seconds squared now. Now I've got that. And a half I can just write as 0.5. So in my calculator, I need to multiply 0.5, 9.8, and 9, right? So I just type in those 3 things multiplied. I'll do it off to the side. 0.5 times 9.8 times 9. I get a height equal to 44.1. And if we look, I think the seconds squared cancel, and we're left with meters. So a meter is approximately a little over 3 feet. So 44 meters would be about probably 130 or 140 feet. So that height ends up being 44.1 meters. Okay. Now let's modify this problem and let's talk about, had this happened on Mars, okay, and let's say we were still at a height of 44.1 meters. It's going to take a lot longer for it to hit the ground. So let me just make this up. Now this is just made up data. Let's put a little spacesuit on this guy because there's not a breathable atmosphere on Mars. And let's say instead of taking 3 seconds, it takes 4.8. Seconds. So now the times 4.8 seconds, we know the height is still 44.1 meters. Let's just say that he found a similar cliff on Mars, similar height. And I want to know, since it took longer, that means that the acceleration due to Mars gravity is a little bit less. Now, on Mars, we don't use the term g anymore. G is specific to Earth, that 9.8 meters per second squared. That's only for Earth. And so when you hear somebody talking about like 1G, 2G, 3Gs, that's always related to Earth's gravity. So instead of using G, we use A. So here's the formula we would use if we were solving for Mars acceleration. It's just rearranged from the one above. So I'm going to plug in 2 times 44.1 meters divided by t squared. And now time we said was 4.8? Oh, I can't scroll. 4.8. And it's t squared. So I need to remember to square it. So again, I'm just going to do that first. 4.8 times 4.8. 23.04 seconds squared. And then 2 times 44 is 88.2. So now that I've got that squared taken care of, I can do 88.2 divided by 23.04. Oops. And I get 3.82 meters per second squared. Give my pen a second to come back. Okay, and so that would be the acceleration on Mars' surface. Oops. Mars's surface. Okay, compared to Earth, which is 9.8. Now, we're going to have you guys do a lab, and we're hopefully proving that 9.8 value. So your goal this time is to solve for G. So the formula we're going to use for the entire lab is going to be this one. And we're solving for G on Earth's surface. Okay, so if you need to solve for G, you're going to need the height that you drop an object from and the time. So I'm going to show you one of the clips that Mr. England and I made. So let me switch to that now. It's a short clip. We'll talk about it in a second.
Yep. Got it.
Okay, I'm going to drop this from 2.7 meters. All right, so you guys will see that I have, go back to my whiteboard. In that video, that was from a height of 2.7 meters. Okay, so 2.7 meters, and I dropped that ball, and we're going to go back and look at that stopwatch. Now, I put a stopwatch on the screen that tells us how long the ball is in free fall. So let's go back and play it.
Yep. Got it.
So again, 2.7 meters.
From 2.7 meters.
Takes 0.73 seconds.
Stop that one.
Okay, so here's what we're going to do. What we're going to do for the lab. We have 6 videos for you. I'm going to do the first trial, or the first video. Okay, and we're going to go through and we're going to calculate G. So the way we do it, I had that blue basketball. Okay, from a height of 2.7 meters. You guys will need to make this data table, and you'll see how it works. So trial 1, blue basketball, 2.7 meters. I watched the video. That object took 0.73 seconds to fall to the ground. So now I need to calculate G. So to do that, I need to square my time. So I'm going to take on my calculator 0.73 times 0.73. I'm going to write down it's a smaller decimal, 5329. Okay. And then to get G, I need to use my formula from the previous page. So it's 2h divided by, t squared. So I will type into my calculator 2 times 2.7 divided by 0.5329. Okay, so on your calculator, do the multiplication first. 2 times 2.7, enter, divided by 0.5329, enter. And I got a value of 10.13. So you can confirm. You guys should check on your calculator. Right? Double check. You can type in 2 times 2.27, or 2 times 2.7, and then divide by 0.5329. You should get a value of 10.13. Now that's our estimate of G for one trial. Okay, I think there's another video where I do a softball. This is in Mr. England's room, again at 2.7. Then we go to the gym. And I think in the gym we do a few objects. You're only going to test, so I think, and you can fill this in now. I think I do the blue basketball again and the softball. We're going to say save the pie plate flip for later, and I'll talk about that in a second. So only do in the gym, I think it's like 4.8 or 4.85 meters. Okay, so you've got those. And then outside, Mr. England and I did 2 more trials up on the top of the school. We did the blue ball and we did a pumpkin. So be sure to watch those videos. It was really fun. Kind of scary to film. It's really high up there. So each video tells you the height and the time. Okay, so hopefully those are the 6 trials you're gonna get. Now you're gonna get a value here, 3, 4, 5, 6. You'll fill in your whole table, right? You're gonna have 6 values for G. And the reason why we fill multiple, there's always little error. Like how I release the ball, or how I throw the ball or pumpkin out. Sometimes I wasn't throwing it perfectly horizontal. Sometimes the video clips when the object's moving really fast. Sometimes the frames aren't fast enough to actually get where it hits the ground. So there's little errors. So the way we get around that is we find lots of values and then we average them. So here's the point of the lab. Once you have these 6 values, you're gonna average, right? And report the average value for G from those 6 clips. And Mr. England and I have kind of checked out what the results were. So hopefully your answer is in agreement with what we calculated. Okay, so that's part 1 of the lab, is to make this data table, watch the 6 free falls. There aren't 6 video clips. Some of the clips I drop multiple objects at once. So you'll just have to watch the video. I put timers and stopwatches for all 6 objects. Okay, so that's part 1. And then part 2 is going to be the video analysis. Okay, you're going to analyze 2 things. Probably just the blue basketball in the gym, and then the pie plate in the gym. Okay, now this one you don't need a formula for, but you are going to need to use some software called video analysis. So the way you get to video analysis, I'll have a link on the Canvas page for the lab. But let me show you how this works. When you click on the link, it's going to bring you to a page that looks like this. It's going to ask you to import a file or to choose a file. Now, the sample videos weren't filmed by Mr. England and I, or me. So you guys will need to choose a file, and you're going to need to tell it the location of our video. So you will need to download I think it's called, let's see if I can find it. It's called the G Blue Soft Pi from 4.85 meters. Now you can download the video to your Google Drive, and I know I'm in Windows, you may be on a Chromebook. So on a Chromebook, you can just save the video to your Google Drive, and then when it asks for a video here, you can hit choose file, and you can tell it where that file is on Google Drive. Takes a second to load, but you're gonna see this interface. Okay, now here's the tricky part. Okay, you need to scroll this video around, and you need to find the start of the free fall. So I'll help you out for the blue basketball. See if I can find it. Oop, a little too far. Okay, if you want to go frame by frame, you can use the skip forward and skip backward, but what I'm looking for is my hand to release the ball. There's the 0 mark too. So in this video, I've added that stopwatch. It'll make it easier. Okay, now that's the start of the free fall. So once you have the start of the free fall with this cursor, okay, you need to set up a couple things. You need to set up a scale bar to tell it how high the ball is, and then you're going to need to track it. So to set up the scale bar, you click on this system button. Now, and again, this is estimates, so it doesn't have to be perfect, but I'm going to select the bottom of the ball down to the floor right below me. If you really want to be precise, you can fast forward the video and find where the ball hits, but this estimate is good enough. Okay, now that is 4.85 meters. So I come in here and I tell it on the video, 4.85. That scale bar that I put in is equal to the height, right, of the ball. So 4.85 meters. Okay, after you've got that, we're not going to mess with the origin today. You can leave that alone. You're going to click on add, and you're going to start clicking on the ball. Now this is a little confusing. If you click the track button, it brings up this crosshair. You can ignore the crosshair. I've done some tests. The auto tracking, like the computer's not smart enough to find the ball. I think the video file, it's just not high enough quality for it to track the ball. So you want to click the track button again, and you want to get to this cursor without the auto tracking. And all it's waiting for you to do, click, click. And you guys, this takes a little while. You're just aiming for the middle of the blue ball. And so I'm moving my cursor. And every time I click my mouse button, what it's doing is it's moving the video ahead one frame. So you guys can see I'm currently on frame 215. So down here it tells you what frame you're on. And when you click, so again, aim for the center of the ball every time. The ball gets harder to see because it is a little blurry because it's falling quickly. We're going to talk about the shape of this graph. See, I'll finish this one up. You guys will recreate this one. All right, so I'm kind of getting to the point. I think it just hit the ground and it's going to start bouncing back up. So we only need to get to the point where it hits the ground. So what you've done is you've just analyzed frame by frame what that free fall looks like. And you guys can tell up at the top, the ball was traveling slowly. Those dots are really close together. And at the bottom, okay, the free fall, this was moving, the ball was moving much more quickly. So the spacing between frames got larger. So what that tells me is that ball was accelerating the whole way down, right? And it was accelerating due to Earth's gravity. And you can see that shape if you look at this blue curve. So this blue curve is the position of the ball. It starts up high at about, it's actually, I think it's plotting it a little wrong. It says 5 meters. Let me see if I can turn that off. I'm going to get rid of the X graph. See if it's any better. It says it's 5 meters high, and then it's going down to a height of a little bit, yeah, that's correct, a little bit under a meter. So it's falling that 4.85 meters. Takes a little over 0.9 seconds. And you guys can see this graph is getting steeper and steeper, meaning the ball is falling faster and faster due to Earth's acceleration. Now the other thing you can do is you can click on this, and instead of graphing y, which would be the height, you can graph the y velocity, which is how fast it's falling. Now this one's a little harder to read, but you guys can see the velocity is getting, I know it's going downhill, but what it's doing, it's getting bigger and bigger in the negative direction. So the ball is falling faster and faster, and the velocity keeps increasing, or I should say like speeding up. Now it's speeding up downwards, so that's why it's going negative, but that downhill slope tells us the ball is speeding up. Okay, so then when you want to track the next item, I think it's easiest. I know the other items are on there, same video, but I think it's easiest to reload the video. So just hit File and New Experiment. You don't have to save these. You can choose the same file again. Okay, and then this time you can see I dropped multiple objects. So here is a softball. You could test the softball if you'd like. It should look really similar to the blue ball. It might get lost in that yellow background, so it might be a little trickier. And then the one that I want you guys to analyze, and that the questions, there's questions on the lab that you need to answer, is about this pie plan. And the pie pan is not going to fall or accelerate the same as the blue ball. And there's some reasons we need you guys hopefully to think through. So you'll scroll, and if this helps, I can maybe tell you the starting frame. Let's see if I can do this. You can see Linus, he's anxiously awaiting the Pi 10. Gotta be any time now. There we go. So it was frame number 853. So you can kind of fast forward to frame 853, but you will do the same thing. You'll set up your scale bar. If you don't set up your scale bar, some of these velocities that it shows might not be correct. But after your scale bar is set up, again, quick reminder, hit system. Gonna have to estimate where my hand is. From there to there is 4.85. Click on add. And then I just start clicking on the Pi 10. Okay, I'm not gonna do all this one for you. And you gotta watch where the Pi 10's at. It's a little harder to see. Smaller. Okay, so you guys can see, I'm just gonna continue doing that until the Pi 10 hits the floor. Okay, once you've generated those graphs, then you should answer the questions in the lab. It might be even helpful to have the lab questions up so that you can see what questions are being asked as you guys do this. So, okay, that's part 2. So let's just recap. Part 1 looks like this. Make a table. 6 trials. Watch all 6 objects falling. Use the stopwatch that's on the screen and the heights that are given in those videos. Okay, I either say them out loud or I put them on the screen for you. Use those heights, and you're going to go through and use this formula. 2h over t squared, calculate g. Do it 6 times and get an average. Okay, once you guys have your average g done, you move to part 2. And part 2, again, you're gonna analyze the blue basketball in the gym, the pie plate in the gym, and answer the follow-up questions. Okay, and those will be in the assignment. It'll be just like last week's lab where we were rolling cans. There's going to be a little canvas. It's set up as a quiz, but really it's open-ended questions that you guys need to respond to. Tell us your results. Give us some explanation on some of the questions, and then hit submit. Okay, so hopefully this makes sense. It's this is the lab for the week. You don't have to go out and collect data, but you do need to analyze it. Okay, so we know it's confusing using this software. So if you have problems with it, why don't you guys try this sooner than later? So hopefully Monday, Tuesday, you guys are logging in and trying the lab. And then Wednesday, Thursday, Friday, we can be answering questions, getting help. Maybe we have some problems running the software. But we'll see how it goes. Okay, good luck. Try your best. Make sure you're turning in your work. And we'll see you guys on the Zoom meeting.